The next first hop redundancy protocol we're going to cover is Gateway Load Balancing Protocol, or GLBP. Now, in the case of HSRP, you saw that router 1 became active and router 2 was just sitting there in the standby state, making this link not handle any load. Which means router 2, you bought it, you're paying for it, you're paying for this internet connection, but you're wasting bandwidth and you're not really using it because it's just sitting there in the standby state. With GLBP, it takes an active-active approach to first hop redundancy. Now, real quick, few things about GLBP. GLBP routers send hellos to the multicast address 224.0.0.102 every 3 seconds to UDP port 3222. Now, with GLBP, once it's configured between router 1 and 2, you're going to elect what is called an active virtual gateway. Now, an active virtual gateway assigns a different virtual MAC address to each member of the group. So let's say router 1 and router 2 are going to be part of group 10, GLBP group 10. Router 1, let's say, is elected as the GLBP active virtual gateway. In that case, router 1 is going to assign itself a virtual MAC and a different virtual MAC to router 2. Then there's a concept of the actual active virtual forwarder. The active virtual forwarder is the router that is actually forwarding traffic. So what will happen is when host 1 tries to send traffic out to the internet and it sends out an ARP request for the virtual GLBP virtual router MAC address, router 1 will return its own MAC for host 1. Then if host 2 sends out an ARP request for the 150.101.45.10 address, which is your virtual router address, router 1 will actually return router 2's MAC address in this case. So what will happen is when host 2 is sending traffic out, router 2 will take care of that load. When host 1 is sending traffic out, router 1 will take care of that load. So in this case, both routers are forwarding traffic, both routers are active, but for different hosts on the network or on the data link. This way, you get a better bandwidth utilization, and unlike HSRP, where one router is sitting there doing nothing, both routers are being used. So router 1's role is to return different virtual MAC addresses to the hosts that are ARPing for 150.101.45.10. And router 1 will begin with itself, give itself a virtual MAC address, and return that to the first host that ARPs for 150.101.45.10. Then the next host that ARPs for the same address will get a different virtual MAC address, which actually belongs to router 2, so router 2 can do the forwarding for host 2. The configuration for GLBP is pretty simple. Again, instead of the word HSRP, I'm saying GLBP. Then the group number, so GLBP 10, IP, and the virtual IP. And then GLBP 10 priority 105, the default being 100, and it varies between 1 and 255. So since I said GLBP 10 priority 105 on router 1, and I said GLBP 10 priority 100 on router 2, router 1 becomes your active virtual gateway. And router 1 will be responsible for assigning different virtual MACs as default gateways as different hosts ARP for the 150.101.45.10 address. Again, on router 2, I've said assign the same group, GLBP group number, GLBP 10 IP, and then the virtual IP. And that concludes the lecture for GLBP.